Alright, so today we're going to go over how to test phase alignment and phase out a main service panel when you can't get those service entrance conductors. So for the sake of this training, let's assume that this is a meter main combo. There is a meter here and you do not have access to these service entrance conductors. And let's assume that this is our microgrid interconnect device. That could be the Tesla gateway, the Franklin A gate. It could be the SolarEdge backup interface. It could be the Enphase IQ system controller. Let's just say this is a SolarEdge backup interface, just for example. And we're going to say this red wire lands in the L2 lug in the backup interface, and the black wire lands in the L1 lug in the backup interface. Since we can't get CTs on these service wires, we're instead going to have to group the branch circuits and clamp them separately. So what we'll do is we'll start by figuring out what phase is L1 on. So we're just going to call L1 here. We're just going to put a piece of tape on L1. We are going to turn our voltmeter to volts alternating current. And now we need to figure out, okay, we've got our L1 CT terminated in the L1 CT port in the backup interface. Now we need to know, where are we putting the L1 CT? Which is L1, right? Is it black? I don't know. It doesn't matter what color it is. It matters what phase it's on. So what we do is we get our trusty voltmeter. So anything on the same phase is going to have 0 volts. If you're on opposite phases, you're going to have 240 volts. So essentially, right, we're going to put one end on the L1 lug going into the backup interface. Next, we're going to go over here and figure out what phase is L1. So let's try red is 240, black is 0. So that is the black coming out of this panel is in fact the black coming into this panel. So this is our L1. So let's go ahead and mark that with some tape. We know that this is L1. Now you're going to want to do this with everything you're going to want to test. Obviously you're going to have to test energized. Use your own company's safety protocols there. When you go and start grouping branch circuits, you're going to want to de-energize the panel. Alright, so next, where's L1 and the rest? I mean, you can do it two ways. You can just count up the bus bar. So we know this is L1, that's L2, L1, L2, L1, L2, L1, L2. The other option is, right, we can just test. So we're on L1. We got 0 volts. Here we got 240 volts. Right, that is L2. We got 0 volts. Right, this red wire coming out of the breaker is L1. The black wire is 240 volts, so that is L2. We do not care what color these wires are. And it's just going to go like that all the way up. L1, L2, L1, L2, L1, L2. So in this case, pretty much all the black branch circuit conductors are actually L2, which is counterintuitive, but we just don't care what color it is. We care that it's on the same phase as the conductor going into the backup interface. So, again, we'll test the bottom here. That is L1. So we're essentially just going to mark every conductor going up. That is on the L1 phase. Alright, so we know our L1s, we know everything else is L2. We don't have to worry about anything over there, and we don't have to worry about the service entrance conductors. So next, we de-energize the panel, and we group all the L1s together. In this case, because this one's so big and it's down here, you're going to need multiple sets of CTs paralleled together. So you're going to take, you know, a Wago connector, or depending on the manufacturer, maybe you're going to have a Y splitter, but you're going to take 2 L1 CTs, paralleled together, landed in the L1 port in your backup gateway. or in this case backup interface. You're going to put one of them on this conductor here, on the L1. Again, each manufacturer is going to have the CTs facing a different direction, so just be aware of the specific manufacturer you're working with and what direction the CTs need to face. You're going to take the rest of these L1 branch circuits. You are going to group them together. You're going to wrap a zip tie around the group of L1s, and you're going to put one of the L1 CTs there. Then you're going to go back through and do the same thing with the L2 phase. You're going to pull all the L2s out, wrap a zip tie around them in a bundle. You're going to put the L2 CT there. You can put the other L2 CT here, right? We want to monitor all loads. So that's going to be all loads being fed, in all the critical loads being fed from this circuit, battery, solar, and critical loads. And then we're going to be monitoring all the non-backed up loads here. And the reason for doing this is so that when the customer programs their battery to offset their utility bill anytime during the day when the grid is working, and they go to use any power in their home, regardless of if it's in the backup panel or the non-backed up panel, the batteries are going to discharge to meet those loads, therefore preventing the customer from purchasing that expensive utility power. Again, to test phase alignment, we're going to want to make sure we keep the L1 and the L2s consistent through the entire system, that at no point do we cross L1 and L2. So not only can you do that by carefully color coding the wires and tracing them all the way, once you're done, you can verify with a voltmeter. So first, what you do is you turn the voltmeter to volts alternating current. From there, you take one probe, you find where the L1 CT coming out of the energy meter is. You trace that and you figure out, right, it doesn't matter if it's black or red or pink, right? It just matters which wire is the CT terminated into the L1 port of the energy meter. In this case, it's the pink CT. So we're going to check that lug, and then we're going to put our other end of our voltmeter on the L1 lug in the backup interface. We want to see 0 volts. We're then also going to make sure that, say, if we had a backfed breaker connection, we didn't swap phases there, right? So we put it on the black wire leaving the breaker to the L1 lug. Again, 0 volts. We want to see 0 volts. That means we are on the same phase. We check between the L1 lug incoming in the backup interface to the L1 lug on the circuit breaker feeding the inverter, 0 volts. Lastly, we check that to the L1 lug going into the solar inverter. We want to see 0 volts. If at any point we get 240 volts, you have crossed phases somewhere and you need to fix it. Now, another common issue that you're going to see is when you do this, right, maybe you can't reach. You know, these voltmeters aren't very long. It's about an arm's length. Maybe the main service panel and the backup interface are 20 feet apart. Well, you know what? There's no problem there, because what you can do, so this is obviously for demonstration purposes only. This wire could be 1 foot or it could be 30 feet. But essentially, to extend this voltmeter, you're going to take your wire, you're going to take your voltmeter, you're going to take both ends, you're going to wrap it up in a wire nut. You make sure it's nice and secure. Then you wrap a zip tie, I don't have one on me, around it and tighten it down really hard to make sure they're not going to separate. And then you wrap it up in electrical tape to make sure you've got a nice solid connection. This is not going to come apart while you're testing high voltage electricity. Now always abide by the National Electric Code. Use your own company's safety protocols. This is for educational purposes only. But now, in this case, right, you could reach You could have someone on the inside of a customer's home 30 feet away with one end and someone else at the other end with the voltmeter testing equipment that's quite a far distance apart. Okay, lastly, this is how you test phase alignment when you're by yourself or in a situation where you can't reach both pieces of equipment. What you can do, let's pretend this is the main service panel, and we've got our L1 CT on this black conductor. Well, we could take that wire end of the voltmeter extension, land it in a single pole breaker. We take that breaker, we follow that L1 conductor down, we find the first open stab on that L1 bus bar, and we turn this breaker to the off position. Again, you would want to do this while the panel is de-energized. You would snap the breaker into the L1 lug. You would turn the breaker on. You would energize the panel. You would turn your voltmeter to volts alternating current. And then, you know, if you're on the same lug, you get 0 volts. See that? If you're on the opposite lug, you'll get 240. Now let's just pretend this right here, the sub-feed lug kit, is feeding our backup interface, right? Black wire, L1 CT. This is L1 feeding the backup interface. Uh-oh, we've got 240 volts. That would mean someone did not pay attention when they color-coded these two wires. The red wire is actually on the same phase as the black wire up here. So, assuming we want to just keep black as L1, we would want to swap these wires to make sure that our phases are aligned. Hope this was helpful. Thanks so much for watching. We'll see you again next time.